Formation of amines. Amines can be formed by nitrile reduction. In nitrile reduction, you can use lithium aluminum hydride in ether, or you can heat it with hydrogen gas over nickel catalyst. Alternatively, you can do an amide reduction. For an amide reduction, you will have a 1 degree amide being reduced to form 1 degree amine. And in the reactions, you will find that the similar to nitrile reduction, all of them will accept 4 hydrogen. And in this case, 2 of the hydrogen used to produce water molecules. To continue, 2 degree amide will be reduced to form 2 degree amine, and 3rd degree amide reduced to form 3rd degree amine. Finally, you can also produce amine by nucleophilic substitution of halogenoalkane. So amines can be produced by nucleophilic substitution of halogenoalkane. You can do that using ammonia reacting with haloalkane and ensuring that haloalkane is limited. So in the case, the reaction will stop here. There's limited halogenoalkane. So this will be the ethyl amine that you get. Alternatively, you could also start the reaction by using an amine to react with your halogenoalkane. And that will allow you to produce, in this case, a 2 degree amine. And again, since halogenoalkane is limited, the reaction will not cascade. Alternatively, you could also use a 2nd degree amine to react with halogenoalkane to produce a 3rd degree amine. Or you could use actually your 3rd degree amine to react with halogenoalkane to give a quaternary ammonium salt. And it is also important to highlight that if any of the halogenoalkane reacts either with amine or ammonia, and halogenoalkane is in excess, then the reaction would definitely continue to cascade until you end up with quaternary ammonium salt. Finally, we're looking at the hydrolysis of amide. In the hydrolysis of amide, we can do so using alkaline hydrolysis. Acidic hydrolysis will produce the salt of the amine. So, for example, if I were to do acidic hydrolysis of this 2 degree amide, I will end up with NH3 plus instead of NH2. So that's the reason why you use alkaline medium. And you find that you cannot produce amine using hydrolysis or by hydrolysis of 1 degree amide, because when you hydrolyze 1 degree amide, it produces ammonia. If you do alkaline hydrolysis of 2 degree amide, you'll produce 1 degree amine, while if you alkaline hydrolysis of 3rd degree amide, you'll produce 2 degree amine. So this is a summary on how the various amine can be produced. To kick off, we can say that nitrile can react with lithium aluminum hydride under reduction to produce your primary amine. And your primary amine can be produced also by reduction of primary amide. And primary amine could react with your halogenoalkane with excess amine, of course, and it will produce your secondary amine. Likewise, secondary amine in excess reacts with your halogenoalkane to produce your tertiary amine. And tertiary amine in excess reacts with your halogenoalkane to produce your quaternary ammonium salt. Or any of the amine can react with primary, secondary, or tertiary halogenoalkane with halogenoalkane in excess, and all of them would actually cascade till you end up with quaternary ammonium salt. Finally, when you decide to reduce your secondary amide, you get your secondary amine, and similarly your tertiary amide to get tertiary amine. We earlier already covered if you reduce your primary amide, you get your primary amine as well. But in hydrolysis, it doesn't quite work that way, because if you were to hydrolyze your secondary amide, you actually get your primary amine. And alkaline hydrolysis of your tertiary amide will produce secondary amine. One of the possible exam questions that could be asked is also that they ask you what are the ways that ammonia can be produced from organic compounds. To produce from organic compounds, you can do alkaline hydrolysis of your nitrile, or you can do alkaline hydrolysis of your primary amide. You will be able to produce your ammonia. These two are the inorganic reactions that allows you to produce ammonia, whereby ammonium react with alkaline to release NH3. Similarly, nitrate or nitrite can react with Devada's alloy, which comprises either zinc or aluminum in the presence of alkaline medium to produce ammonia as well. Finally, the last reaction that we want to highlight is that ammonia can react with acid chloride to give you primary amide, and your primary amine could react with acid chloride to produce secondary amide, and your secondary amine to produce secondary amide by reacting with acid chloride. And important to note is that tertiary amine cannot react with your acid chloride. So finally, with that, we take a look at the chemical properties of amine. Chemical properties of amine, also 3 reactions, quite similar to carboxylic acid. The first one, certainly it acts as a base because of the availability of its lone pair electron of nitrogen. So it can receive a proton. So it's a proton acceptor, therefore a base, and hence can neutralize any acids. Second reaction that you have is the fact that it can undertake nucleophilic substitution with your halogenyl alkane, which we learned earlier. And any one time when they undertake the reactions, if they are limited, they will end off by actually converting a 1 degree amine to a 2 degree amine, or a 2 degree amine to a 3rd degree amine, or a 3rd degree amine to quaternary ammonium salt. But in the event that halogenyl alkane is in excess, then the reaction could cascade to produce a range of amines and as well as quaternary ammonium salt. The final reactions is when amine reacts with acid chloride. When they react, you actually end up with your amide, and together the byproduct is your HCl. And earlier, as illustrated, tertiary amine cannot chemically react with acid chloride. Finally, in the lab, when amine comes into contact with carboxylic acid, the spontaneous reaction that will happen will be neutralization, as illustrated here. Therefore, it will not be possible for them to form an amide. However, in the presence of enzymes or industrial conditions, they are capable of reacting to form amides. So it's important to take note that in the lab, the spontaneous reaction that will happen will be acid-base, which means they are just neutral. They will neutralize to form actually a complex salt, as shown in this equation. So the way to produce an amide from amine is to react it with acid chloride.